joining today. I thought I'd do a video on Fisher effect. Fisher effect is another parity conditions in financial management. As you know, we talked about the international Fisher effect that connects the exchange rate with interest rate. Then we talked about purchasing power parity, PPP, that connects the exchange rate with inflation. When we look at Fisher effect, this is one formula under arbitrage conditions we assume, or we use it to connect inflation with nominal interest rates. And what does it mean? Fisher effect, proposed by the economist Irving Fisher, explains the relationship between, as said, nominal interest rates, inflation, and real interest rates. And think about this. If you have nominal interest rates, basically the rates you receive from the bank, this component is made up of two areas. One is the real required return, here in our example A, and the inflation premium, I. The formula here, and I change the formula a little bit, is 1 plus R, which is the expected rate of return, also the nominal interest rate. So it depends on which side. If you're the investor side and you invest, then it's your nominal return. If you are the borrower, then this is your nominal interest rate, equals 1 plus A. A is your real interest rate adjusted for inflation, which we will see in a bit, and then you have I, inflation rate. Just a heads up, sometimes they are used differently. Sometimes for nominal interest rate, we actually use I. Many times for inflation, we use P, and many times for the real return, we use R. So just keep in mind what the terminology is. I use R, A, and I for my example. If we change this formula here, we can see that our real interest rate or real return is affected by the nominal interest rate and by inflation. We can simplify this formula. A is approximately R minus I, which means if, for example, if you get 10% from the bank as interest rate, but inflation rate in your country, I, is 2, then your real return is only 8%. Yeah, because yes, you get 10% from the bank. This is your income, your return, but because of inflation, the real purchasing power of the interest rate that you get is only 8%, because you need to subtract your inflation rate. Yeah, so this is the main key, and I like to think about, start with real return first, and then it makes sense to say, okay, this is the money that I get from the bank, which is our R, in my example R, and then your inflation rate is I, and then you can see how the real return or the real interest rate is affected by those components. Yeah, again, this is the approximation which you can use many times. This is the more detailed formula. Yeah, and what you see here, if you change the formula a bit, you can say that basically your nominal return, interest rate, your nominal interest rate, and this is your inflation differential between two countries. So if country A has 8%, 2%, then your inflation should adjust for this as well. So here you have a difference between country D and country F from nominal interest rate perspective of 6%, which would mean, as per this formula, that your inflation differential, so the difference of inflation rates between those countries, should be 6% as well. Which then leads to the conclusion to say currencies with higher inflation rates should have higher nominal rates than currencies with lower interest rates, with lower inflation rates. What it means as well is, why does a higher nominal interest rate indicate higher inflation? This is the main purpose of Fisher effect. The real interest rate, A, is determined by factors like productivity, long-term savings, and investment demand. The real interest rate, A, here or here, does not fluctuate significantly in the long term. Yeah, and also we assume that our real return across countries is similar, because otherwise money would move. So because we keep A constant, that means any change in nominal interest rate or any change in inflation rate needs to be offset by the corresponding interest rate or inflation rate to keep A consistent across countries. Therefore, if a country has high inflation expectation, its central bank typically raises nominal interest rate to compensate investors for the loss of purchasing power. Yeah? Investors demand higher nominal interest rates in economies with high inflation to compensate again for the declining purchasing power. Yeah, and if we look at evidence, countries with historically high inflation like Argentina, Turkey, Venezuela typically have very high nominal interest rates from the banks. Conversely, economies with low inflation expectations, Japan, Switzerland, tend to have low nominal interest rates. Yeah, so here think about A is consistent across countries and also in the long run. That means if there's a change in inflation, it needs to be offset by the nominal interest rates and vice versa. Yeah, let's do an example. Let's assume we have the US has a 2%, and let's look at Brazil. Here we assume A is also 2%. If this is not the case, money would move, and under parity condition, arbitrage opportunities would exist, and you could move money from one place to the other and make riskless profit. So we assume A, our real interest rate, needs to stay constant. If we look at expected inflation, let's assume expected inflation in the US is 3% and in Brazil is 8%. Then what we know, if we use the formula, we would say, let's use the formula over there, A equals R minus I. If we look at US and Brazil, then if we change for R, we want to know what the nominal interest rate is. A plus I. A is 2% plus 3% equals 5%. And for Brazil, again, R equals R minus E. R A plus I equals, again, A remains at 2% plus I is 8% equals 10%. And then here you can see, because Brazil has a higher inflation rate, so the nominal interest rate set by a bank needs to be higher to adjust for loss of purchasing power. Inflation in the US is only 3%, so the nominal interest rate would be set approximately to 5%. Reason here, A needs to remain constant, otherwise there would be an arbitrage opportunity. Yeah, so again, think about inflation. Inflation, it is what drives exchange rates. The nominal rate is a second order effect. In the end, the Fisher effect explains what happens if inflation changes, what would happen with the nominal interest rate, because the real return needs to stay constant. That's all I wanted to do. So again, international Fisher effect extends the idea by predicting that currencies with higher nominal interest rate will depreciate over time due to their higher inflation rates. Okay, thank you so much for listening. I hope you found this useful, and I see you in another video. Thank you so much. Bye-bye.